Alright, here's the Unit 8 review for the final exam. So let's start with number 45. It says find the formula for a sub n for the arithmetic sequence and find the sum of the first 20 terms. So the formula for a sub n for any arithmetic sequence is going to be a sub n is equal to a1 plus n minus 1 times d. So if we just plug everything in that we know, a sub n is equal to 100 plus n minus 1 times negative 3. Distribute and simplify. An is going to be equal to 100 plus negative 3n plus 3. So that final answer there is negative 3n plus 103. That's my formula for a sub n. And then the summation, for us, we're going to want to do the sum of the first 20 terms is equal to 1/2 n times a1 plus an. So it's 1/2 the total number of terms times the first plus the last. So as 20 is equal to 1/2 times 20, because we have 20 terms, times a1 we know is 100, and an we don't know it, but we just found a formula to find it. So a20 is equal to negative 3 times 20 plus 103. Negative 3 times 20 plus 103. It's going to give me 43. So last thing we have to do is add everything together. So 1/2 times 20 times 100 plus 43, and we are going to get 1430. Alright, number 50 gives us a summation in summation form, and it wants to find the sum from 1 to 25 of that function. That's a linear function, so it's going to be arithmetic, which means I can use the same thing. I can still do an is equal to 1/2 n times a1 plus an, and we can still find everything. So n is first of all going to be 25, because we're going from the first term to the 25th term, so that's a total of 25 terms. So a25 is equal to 1/2 times 25 times a1. a1 is just going to be plugging our first value, this 1 into k. So we got 3 times 1 plus 1 over 4. It's going to be 4 over 4, which is 1. And an, in this case, is going to be a25. Plug in the 25. So we're going to get 76 over 4, and 76 over 4 is 19. So plug in that 19, and then once again we go to our calculator. Got 0.5 times 25 times 1 plus 19. And we get a sum of the first 25 terms, which is 250. Alright, 76. We've got find the sum of that sequence. It is geometric this time because I have an A1 and I have an R, a common ratio. And to do this by hand, the sum of this is going to be 6 terms because I'm going from 0 to 5. So we count in order 0, 1, 2, 3, 4, 5. So of 6 terms. That's going to be A1 times 1 minus R to the n over 1 minus R. So plug in everything that we know. S6 is equal to A1. Easiest way to do it, A1, again, plug in your first term for, so plug in your first term into the equation. So since we're starting at 0 this time, it's 400 times 1.08 to the 0. That makes this whole factor just a 1, so it's 400 times 1, so A1 is 400. And then I've got 1 minus R. R is what's being raised to a power, so that's 1.08 over, 1.08 to the 6th, and then over 1 minus 1.08. And then I'm just going to plug that whole thing into the calculator. I've got 400 times, times 1 minus 1.08 to the 6th over 1 minus 1.08, and I get 2934.37. Alright, 77. Again, it's another summation of a sequence. This time we're going from 1 to 10 of that function, and I'm just going to use the calculator this time because this calculator, our TI Inspire, can do that whole thing for us. So we go to the templates, choose the summation template, and then we put in I, and it's got the equal sign 1. We go over, we do 10, and then times 3/5 raised to the I minus 1 power. And then we need to make sure we go up to the top of the template and we get 10. So I've got it plugged in here, just like it shows on the paper, and I hit enter, and I get that weird fraction. So I'll change it to a decimal. Just make something in here a decimal. It doesn't really matter what it is. Do it again, and this time I get the summation is equal to 24.85. Alright, 79. This is a sum to infinity of a geometric sequence. So the sum to infinity of any geometric sequence is S infinity of A1 times 1 over 1 minus R. That's all it is. So we need the first term, we need the common ratio, and we're done. So my first term, it's going to be whatever I get when I plug in 1 for I, because this is starting at 1, so I plug it in there. So not S1, A1 is equal to 4 times 7/8 to the 1 minus 1. This whole thing is going to become 1, because 1 minus 1 is 0. So A1 is just 4. And R is going to be whatever's in the parentheses. So this little guy right there is R. So I've got my sum to infinity is equal to 4 times 1 over 1 minus 7/8. And I'm going to put that into the calculator. 4 times 1 over 1 minus 7/8, and we get 32. Alright, 80. Got another sum to infinity. So again, we need A1. A1 is going to be 6 times 1/3 to the 1 minus 1. We're using the 1 here because I starts at 1. And once again, this whole guy is going to become just a 1 because this exponent is 0, so I get 6. And R will be 1/3. So my sum to infinity is 6 times 1 over 1 minus 1/3. So in the calculator, I've got 6 times 1 over 1 minus 1/3. And I get a sum of 9. Alright, number 83. This one, company buys a fleet of 6 vans for $120,000. They depreciate at a rate of 30% per year for 5 years. Part A says find a formula for the nth term of a geometric sequence. That gives the value of the fleet T full years after it was purchased. So all we need to do is it's going to be geometric, which means it's going to be in the form of AN is equal to A1 times R to the N minus 1. So in our case, we're going to have AN, or AT for time, is equal to A1, that's our initial value, which is $120,000, times our rate. So if we're depreciating at 30% per year, we're retaining 70% every year. And we need to be careful about the exponent though, because we don't want t minus 1, because that means that it's going to depreciate like in the first year. That's going to mean that it doesn't depreciate, because 1 minus 1 is going to be 0. So I don't want that. I want to make sure that it depreciates by 30% in the first year as well. So that's just going to be 120,000 times 0.7 to the t. Part B says find the depreciated value of the fleet at the end of 5 full years. So that's A5, which is 120,000 times 0.70 to the fifth. 120,000 times 0.7 to the fifth. And I get a total of $20,168.40. Alright, number 84. Deposit is made $75 each month, 4% interest, and we want to know the balance at the end of 4 years. Oh, sorry, the 4% interest is compounded monthly, and we want to know the balance at the end of 4 years. And they gave us a big hint. They told us that it looks like that, which if we think about the compound interest formula, A equals P times 1 plus R over N to the NT. N is going to be the number of times per year that we compound it. R is the rate, so I have 75 is my starting value, 1 plus 0.04 over 12 times NT. NT is the number of times that I'm doing it, times the number of years. So it's a total of 48 times. But since it's an annuity, I'm going to add $75 each month. So that's why we have a summation. So this really turns into just a summation from T equals, well, we'll use N equals 1 to 48 of 75 times 1 plus 0.04 over 12 to the N power. And since we're doing that, I can use my calculator. I get N goes from 1 to 48. And we're going to have 75 times 1 plus 0.04 over 12. And that is raised to the N power. And I'm going to have a total of $3,909.96. Okay, 105 is a binomial expansion. We need to expand x plus 5 to the fourth. Remember that there's a couple ways we can do the expansion. For anything that starts in the form of, let's go x plus y to the n power, that's going to be expanded as nr times x to the n plus nr times x to the n minus 1 y to the 1 plus a bunch of stuff plus nr x to the 1 y to the n minus 1 and finally plus n over r times y to the n. Remember what we're doing, this n over r, that's the n is the power that we're given with. R is the power of the second factor, so it's in this case the y. So we start with, this would be n over 0, n over 1, n over 2, and my first factor, my first variable, in this case the x, counts down from the highest power, so it's going to be n, n minus 1, n minus 2, n minus 3, and my second variable counts up from 0, so 0, 1, 2, 3, all the way to n. Okay? That's the long way to do it. The short way, these nr's come from Pascal's triangle, or we can shorten it with Pascal's triangle if we're only going to something like the fourth power. Remember, Pascal's triangle starts with a 1 for n equals 0. For n equals 1, we have 1, 1. n equals 2, I have 1, 2, 1. n equals 3, 1, 3, 3, 1. And for n equals 4, 1, 4, 6, 4, 1. And these are my coefficients of each term in this sequence. So this 1, 4, 6, 4, 1 will replace each of these. So really it's n, 0, n1, n minus 1, and n. Okay? So for my expansion here, x plus 5 to the 4th, I'm going to have 1 for my coefficient from the table times x to the 4th plus 4 from my triangle times x cubed times 5 plus 6 times x squared times 5 squared plus 4. I'm going to have to erase some of this, plus 4 times x to the 1st times y to the 3rd plus 1 times 5 to the 4th. So this is what happens when I expand out x plus 5 to the 4th using binomial expansion, and now I can simplify. So 1 times x to the 4th is just x to the 4th plus 4 times x cubed times 5 is going to be 20x cubed plus 6x squared, 5 squared. So 5 squared is 25. 25 times 6 is 150x squared plus 4 times x times 5 to the 3rd. So 5 to the 3rd is 125 times 4. That's going to be 500x plus my last term is 5 to the 4th. Oops. I'm going to get, I have no idea what's going on right now. So we get 5 to the 4th, which is 625. And that is my binomial expansion for number 105. Alright, 107, last one. Again, it's binomial expansion. This time it's a minus 4b to the 5th. I could do it the exact same way because it's just the 5th row, so it would just be one more row on top of the one that we did on the previous one. But I want to do it with the combination so you guys can see it both ways. So for this one, n is 5, so we're going to have 5, 0, because it's my 0th row, because it's where we're starting, times a to the 5th, and then there's no b in this case, plus 5, 1 times a to the 4th times negative 4b to the 1st, plus 5, 2 times a 3 cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative 4b squared, plus 5, 2 times a cubed negative make that a little bit smaller. Fit it all in there. Plus 5, 3 times a squared times negative 4b to the third. There we go. 5, 4 times a to the first times negative 4b to the fourth plus 5, 5 times negative 4b to the fifth. And just to clarify one more time, you'll see that this 0 or this 1 or this 2 always corresponds to the exponent on the second variable. So 2, 2, 3, 3, 4, 4, 5, 5. And then from there, we can get all those coefficients using our calculator. We do menu, it's under probability, it is a combination, and so it's NCR, and we're just going to type in 5, comma 0, which we should remember that's just always going to give me a 1. I have 1 times a to the fifth plus 5, 1 is just going to give me a 5, so it's 5 times a to the fourth times negative 4b, because it's negative 4b to the first, plus, I'm going to do my next one, probability combination, and this time it's 5, 2, so I get 10 a cubed times negative 4b squared is going to be 16b squared when I multiply that out, plus 5, 3, menu, statistics, oops, not statistics, probability combination, 5, 3, and I get another 10, and this time it's a squared, and negative 4b to the third, that's going to be negative 64b cubed, plus, since these coefficients were the same, I know that my list is repeating, so the next one's just going to be a 5, a, and then negative 4 to the fourth. Make sure we put it in parentheses so we don't forget our negatives, is 256 b to the fourth, and then my last one, 5, 5 is a 1, and negative 4 to the fifth is negative 1024 b to the fifth. So I've got that, and now I can go ahead and simplify everything completely. So I have a to the fifth minus 20a to the fourth b plus 160 a cubed b squared minus 640 a squared b cubed. 256 times 5 is going to be plus 1280 a b to the fourth, and then minus 1024 b to the fifth. And that's my final answer, and that's it for Unit 8.